Let's take a look at how to write explicit formulas for quadratic sequences in series. After looking at several videos and not really liking them very much, I decided to go ahead and create one myself. So here we go. This is our quadratic form. These are the things we'll be filling in. We're going to start by finding common differences, a first common difference for the first row, and this can be done either horizontally or vertically. A lot of the videos that I saw, they did it vertically. That's fine. So subtracting gives us 6, subtracting gives us 10, subtracting gives us 14. Okay, and that is our first common difference. First, we'll call it CD for common difference. Second common difference is simply finding the difference between the next set of sequence of terms, and that's going to be 4 and 4. Okay, we'll call that the second common difference. And then we're going to take whatever that term is and divide by 2 or multiply by 1/2. Okay, I'm going to put divide by 2, and 4 divided by 2 is 2, and 2 happens to be A. All right. Knowing that, that's going to go in that spot right there. Now, this is one type of problem, and this type of problem we'll be solving for A and C, and B will be 0. You'll see that in just a moment. And the second type we'll solve for all three pieces, A, B, and C. In order to get the C value here, we're going to take the A value, put it in front of the x squared term, 2x squared. All right, we're going to write out the first few terms of 2x squared. All right, and those are going to be, if we plug in x equals 1, we get 2. If we plug in a 2, that's 8. Plug in a 3, that's 18. And plug in a 4, that's 32. All right, we're going to take that string of numbers and we're going to subtract it from the original. So we're going to put the original sequence on top. 6, 12, 22, 36. We're going to put our 2x squared term underneath it, which is 2, 8, 18, 32. And we're going to subtract those. And when we do that, we'll either come up with the same value for all of them, or we'll have different values. Those are the two different types of forms for quadratic that we're looking at. So subtracting here gives us the same value, and that happens to be C. All right, if it is the same value, that's C, and we are finished with our quadratic formula, explicit quadratic formula. A sub n equals 2x squared, which came from here, and then plus 4. We can check that by plugging in 1 for x. That would give us 1 squared is 1 times 2 is 2 plus 4 is 6. Plug in that 2, we'll just do a couple of these. 2 squared, 4 times 2 is 8 plus 4 is 12. All right, you can check that by plugging in. Check by subbing 1, 2, 3 for x. Okay. All right, the second type of problem we're going to do, and we'll just put a little line under this to separate them, is when these numbers are not all the same. And we're going to use the sequence 2, 7, 14, 23, 7, 14, 23. Okay, let's do the same process we did up here. Let's go ahead and find those common differences. We'll do first common difference. Oops, and that's going to give us 5, 7, and 9. And then our second common difference, again, these can be done vertically as well as horizontally. Second common difference is going to be a 2. We always divide that by 2. All right, so divided by 2 to get a 1. And 1 is the A value in our quadratic. Ax squared plus bx plus c. And then we're going to go ahead and write out the first few terms of 1x squared. Obviously, we don't need the 1, but we'll put it there since we know that a is 1, just as a teaching tool. Plug in 1 and get a 1. Plug in 2 and get a 4. And you probably recognize this as the standard quadratic sequence. Okay. 1, 4, 9, 16. We're now going to put, once again, we're going to put this underneath the original sequence. So we're going to put original as 2, 7, 14, 23. We're going to put this underneath it, 1, 4, 9, 16, and we're going to subtract them. And this time you'll notice that we get something different for each of these terms. 1 through 5, 7, that's 23. And notice that there is a common difference between each of these terms of 2, which makes it arithmetic. All right, so we're going to write an arithmetic nth term sequence for 1, 3, 5, and 7. Remember, that's a sub n equals a sub 1 plus the common difference times n minus 1. All right, which just use these terms to go into this form. The common difference is 2. So we get a sub n equals a sub 1, which is 1, plus the common difference, which is 2, times n minus 1. And when we write this, we finish distributing 1 plus 2n minus 2. So 2n minus 1 is my arithmetic formula. And this piece right here happens to be my B and my C for the quadratic term. All right, so my final answer for this particular quadratic explicit formula is a sub n equals 1x squared, or x squared, and then I'm going to attach this as the second two terms, plus 2x, we'll replace the n with an x, minus 1. Okay, just remember that this part came from our arithmetic formula. Okay, and then I can check this again, just like we did up here in the first example. We can check this by simply plugging in 1, 2, 3. So check by subbing 1, 2, and 3 for x, and it will give us the original sequence. I'll let you do that on your own. Okay.